So I'm going to be talking about well, I'm Pete Broderick, by the way, if you're not familiar with me. I've been working with Solution Street for about 3 years now. So I'm going to talk about a new programming language called Elixir. And just to give you a little background on Elixir, it is actually a language that's built on top of the Erlang runtime. And Erlang was designed with a few things in mind. They wanted to build a system that was massively scalable, with high availability and real-time systems in mind. It was developed by Ericsson in 1986 to solve a specific problem in the telecommunications space. They wanted to build software for phone switches. And so if you imagine how a phone switch works, you'll have a caller A calling into a switch, trying to connect with a receiver B. The switches will have to do communication and try to figure out how to connect A with B. So this was the specific problem Ericsson was trying to solve. And if you imagine the modern web with new HTML5 features like WebSockets and server-sent events, is actually a very similar concept about how we have these clients and we want to open up persistent sockets between the server and a client. So if you imagine applications like Facebook chat or WhatsApp, they actually use Erlang to power their systems. And WhatsApp has reported something like, this was a year ago, they were running 10 servers, 10 very beefy servers with like 22 cores, and a single server was able to handle millions of these chat connections. So Erlang fit their use case perfectly and allowed them to have a very small amount of servers. All right, so now I'm going to talk about Elixir. So this guy, Jose Valem, who's a Rails core team member, he has been for several years now, he wanted to build a web application using a web framework like Rails using Erlang because of the power he saw in it. So when he approached Erlang, he saw some things that he thought were missing. He thought that the syntax was kind of unapproachable. So then he started working on this kind of syntax on top of Erlang, which turned into be an entirely new language called Elixir. So I'm not sure if I already said this. Elixir is similar to like Clojure or Scala that runs on the JVM. It runs on the Erlang virtual machine called Beam. All right, so if we look at some Erlang code on the left, it has this very Prolog-ish syntax. If you're familiar with Prolog, we have these dots at the end of statements. The method or the function encapsulation is kind of odd. It's not super clear what's going on. That all of these functions are inside of this hello module, and we have this export thing up at the top, and with the function name slash a number, which is actually its arity, the number of arguments that the function accepts. So this export is creating an API for this module, and then we have this private method down below that's not exported. So that's how you declare a private method. So if you can imagine a big library with lots of private methods, I can imagine that export statement would get very unwieldy. So if you look over at the Elixir code, especially if you're coming from a Ruby or Python world, it's very approachable syntax. It looks very similar to how you would write code inside of a Ruby module. You have good function encapsulation inside of this hello module, and we have a special def p for defining a private method. So you won't have to have a line of code that explicitly states what your API is for the module. So Elixir and Erlang are both functional languages, which means you have to think about them, you have to approach them a little bit differently than you would an imperative language like Ruby or Python. The control flow will be different. While the languages do have if statements, they're not widely used. You'll see switch statements used every now and then, but you can usually get around using these by doing something called pattern matching, which I'll talk more about in a little bit. All right, so now I'm going to actually do some live coding to show you some Elixir basics.
So Pete, Jeff's saying the delay, and that was him that just got kicked off the call. The delay on here is like 20 to 30 seconds. So I don't know how the live coding is going to go with the...
So do what we can. Do what we can. All right, so the first thing I'm going to show you is Elixir's REPL, which is similar to IRB or whatever the Python REPL is. It's called IEX. And we'll go into interactive Elixir is what it stands for. So Elixir has a few like primitive value types like integer, float, we have a string, and we have something called an atom, which is similar to Ruby's symbol. It has this colon prefix, and you can think about it exactly like you would a Ruby symbol. Fundamentally, they're a little bit different because of how Ruby is object-oriented, and it has to do with like mutability and other things like that, whereas Elixir is different, but the way they're used is exactly the same. So you would use an atom in Elixir basically to make sure that it's always, if you wanted something to always be the same, that you can pattern match against. So :Pete will always be equal to Pete. We can bind a variable to Pete and compare Pete with that variable, and it will always be true. Okay, so I'm going to talk about, I'm supposed to pull up my notes here before we got started. I'm going to talk about Elixir's collection types. So Elixir has a few other data types, but they're all built using these two collection types. Elixir has something called a tuple, which is similar to an array, and it will take a couple values, comma delimited, like this, and it has like O of 1 random access. So we, like an array, we can find an element at a specific index. So we do this, and we say we want to get the, it has 0 base index access, so if we want to get the second element, we pass a 1, and we'll get 2 out of there. While it's fundamentally like an array, they're used differently. You'll usually see tuples used for pattern matching, and functions will return a tuple with like a status and a result, usually, and then you can pattern match against the status. So usually they're between 2 and 4 values, and you won't have a big array. For something that you want to be big, you would use a list. And a list looks like Ruby's array, like this. And we'll just bind to this list here. And so this list is very different from an array. It does not have, it has O of n random access. So you have to go sequentially through the list if you want to find a specific element. But it's also like an abstract list from Lisp, which is implemented using a linked list. So we have things like the head and tail, where head will be the first element of the list and tail will be a list of the remaining elements in the list. So one thing that I haven't mentioned is that the equal sign is not actually assignment, it's the pattern match operator. And it tries to, if you have a variable on the left-hand side, it will bind its value to the right-hand side so that the two are equal. So it's always trying to make, kind of like if you think of an algebraic expression, it's always trying to make the left-hand side equal to the right-hand side. So because of that, we can do pattern matching and say what pattern will make the left-hand side equal to the right-hand side. So if we want to extract the head and the tail from this list, we can use this operator called the cons operator, which will take, here, let me just demonstrate this on its own first. So if we wanted to add 1 to the list 2, 3, 4, 5, we could do this, and it would give us a list 1, 2, 3, 4, 5. So because of that, we can pattern match using the cons operator and get our head and tail. And then we'll have head and tail. So because Elixir is a functional language, we won't have things like for loops. What we can do, though, is very easily iterate over this list, given that we can look at the very first element and then get the tail and recursively pass that back into a function and then act on the next element. So you can very easily sequentially traverse through a list. All right, so just before I start writing some real code here, just going to briefly go over anonymous functions. We can write anonymous functions. It kind of has a lambda syntax from Ruby. It looks like this. We can say this function will put hello world, and then we can use a little bit of a strange syntax, but it's actually the same as calling an anonymous function in Ruby with this dot and then parens. In Ruby, you do the same thing. You could also use call. That doesn't work in Elixir. All right, so let me get out of here and show you the next tool that Elixir gives you. All right, so we also have this tool called mix, which is similar to like an Ant or Maven, or if you combine the Rails binary with Rake. It's kind of like the two of those combined. You have code generation, and then you also have the ability to like run tests and run different tasks. So I'm going to create a new mix project, and using mix new, we'll call it misc. I'm going to have a bunch of different things I'm going to show you inside, and I want to pass this bear keyword because I don't want it to generate any code for us really. So if you look at the directory structure created, we basically just get lib and test. Our code will go in lib and our test will go in test. Just going to open up Sublime here. Full screen. Show our code. So I'm gonna start with the test file. We're going to test drive some code. And initially it just gives us this basic test to just assert that true is true. So if we wanted to go into misc and run the test, we can run mix test, and you'll see our one passing test. So let's write a real test in here. Let's say we want to test that multiplication works. Multiply will multiply two numbers. So we want to assert that our misc module multiply given 3 and 4 will be equal to 12, which will obviously fail because we haven't implemented it yet. It says undefined function on misc. So we'll go in and implement this function. All right, so let's define a function called multiply that takes two arguments, x and y, and combines them, x times y. Oh, that will help. Thank you. Live coding fun. All right, so our test works. So that's good. Let me show you some other cool features that we have inside of our module. We have module documentation. Documentation in Elixir is first class, so it sits there with your module, which is really nice. So we can say this contains a bunch of junk. If someone wants to use our module, they can, in IEX, sorry, I have to IEX with the context of our mix application. In IEX, they can say, let's look at, use this H keyword, which stands for help, and look at our misc module, and it will show the documentation for that module. So you can do the same thing with built-in libraries like enum, and it will show you how you use map and a bunch of different things about enum. So if we come back here, we also have method documentation, and we can say this multiplies, wow, 2 values, and we can actually give examples. And our examples are going to look like this. This IEX keyword will actually get parsed out of here, and it will be able to extract the example and assert against the result, which is really cool. So we can say, this is how you use this function, multiply with 3, 4, and it will return 12. So we can come over to our test and add a doc test line. Doc test, what do I have to do here? I don't think I have to do anything other than that. Doc test misc. And then I can say mix test, and now we have 2 tests. If we add another example, say 5 times 5, 25, and we have 3 tests. So this is really cool. It's a feature that Python has. We can also go into IEX and look up the documentation for multiply, and it will show us our examples and the documentation. So it's very nice. You know, you can't do this in Ruby. You'd have to go open up the documentation or generate an RDoc or something like that. Okay, so let's move on to some more complicated stuff. So I'm going to implement sum. I'm going to do it in a very different way than you would do in an imperative language. We're going to use recursion and pattern matching. So we'll write a sum function that accepts a list. So it just accepts one argument, and we want to sum the values. So now I'm going to call another function to set up our base total. So we'll pass list to this, and we'll also pass 0 to say the total will start as 0. We're going to define a private function using the def p. By convention, we'll use this this underscore prefix, and it will accept and pattern match against the empty list. If it gets an empty list, it will return the total. Now we're also going to have another private function that will accept a list and a total and recursively call itself with the, okay, so we can pass in the list here, and then we could extract using the cons operator the head and the tail, but we can also do this right in the method signature. We say we want the head, pipe, tail, and it will pattern match against that, and then we can call our sum with the tail, and our total will now be head plus total. All right. Live coding, I'm sure I did something wrong, but I probably forgot my do's, like I do. Thank you. And we can come out of here. I could have stayed in there, actually. And we'll create a list that is 1, 2, 3, 4, 5. And call misc.sum list, and we should get 15. Fantastic, it worked.
What was the second one? What was the first private method do? I understand the last one.
So, okay, so Elixir uses pattern matching in its method signatures. So the first private method is saying, so we'll come into our public method sum, and we'll pass in our 1, 2, 3, 4, 5, and call this private method sum. Now there's two different clauses for this private method sum. We have this first clause and the second clause. And the order matters here. So it's going to look at the first one first and see if it can match the pattern of the arguments. So it matches our empty list and outputs total. So that is that's for our base case when we want to stop recursion. So as it's going through and popping the heads off of tails, eventually it'll have an empty list, and we want to match against that and output the total.
So can you not do if statements?
Yeah.
Because that's a typical recursion. It would have an if in there, right? It's a short circuit versus the pattern match above.
So you can. I wanted to keep it strictly functional.
Okay.
But yeah, you can have if statements. Like if you were to write this Ruby, you just have a if empty return total and then bail out, or return total if empty. Okay, so that's a good example of what a lot of Elixir code will look like. Sometimes they will use ifs to like short circuit things and make things simpler, but mostly it's kept pretty functional.
How does it handle recursion in terms of very big numbers? Does it do it all on the stack, or does it have some way of dealing with?
Well, no. So this is totally tail call optimized because of the way I wrote it. The very last function. Well, the Erlang bytecode will be tail optimized for me based on the way I wrote this. Whereas in Ruby, you have to like tweak the runtime to do tail call optimization. You have to write it even more differently than this. But even without that, I've tested huge numbers of factorial. Erlang hasn't stack overflowed on a number that I was willing to wait for, and Ruby will do it immediately.
Right.
I could show you if we have time. I'll show you at the end. Just remind me. Okay, so let's go back to our presentation. Whoa, what happened? Okay, go back to our presentation. So another thing that I'm not going to live code, I'm just going to show you real quick, are records and protocols. I don't find them difficult to explain like pattern matching, so we'll just look at them real quick. You can define a record in Elixir. It looks similar to like a struct in other languages, basically just giving it different attributes. It defines some getters and setters for you. Use it like you would an object in an object-oriented language, and you can see where we're on the second line of the bottom part, we're calling a time and it's outputting a time, and then on the next line we're setting a time. So the important thing to look at here is that where we're calling the setter, it actually returns a new file info because everything in the Erlang runtime is immutable, which will be important when I talk about concurrency. So you never change an object once it's defined. You will transform it and return a new thing. Another thing that's a pretty cool feature, similar to like a Java interface but a little different, are these things called protocols. So we can define a protocol for what blank means, and then we can implement this protocol for various types. So we can say for an integer, blank is anything, because if you get an integer, it can't be blank. But for a list, for example, if you get an empty list, it might be blank. Or if you wanted to implement this for a string, you might say if it is the empty string, it would be blank. Also, this is showing some shorthand function syntax. You can do this comma do syntax as well and put things on one line if you have very short terse functions.
So when you define your records, does it take functions, or you need to pass functions if I'm attributes?
So in functional languages, generally the idea is that you want to keep all of your behavior separated from your data. So you would define a module that had all of the behavior that you wanted, and then you would just manipulate your data in some way and transform it. So you wouldn't have any behavior
So
inside
I'll be
it.
able to add a protocol.
You would. I'm sorry, I didn't
I
follow.
won't be able to add a protocol to this. You are defining like protocols for integer and let. I want to add it to the record info.
No, you wouldn't be able to do that. Yeah.
There is no such thing as a custom type, right? It's
Or
functional.
struct whatever you.
Yeah, struct. It's just a data. It's just a data. It's a
Yeah,
data
they do have things that are built from tuples and lists. Like you get a hash dict, which kind of behaves like a Ruby hash. All right, so now I'm going to talk about concurrency. How are we doing on time, by the way? This is
36.
36 minutes? Okay. So now we're going to talk about concurrency. Just the way the Erlang runtime handles concurrency is very different than most other languages. If you think about how most languages deal with it, the multi-threaded approach, you'll create different threads, and then if you need to have inter process communication between threads, then you have to have some sort of shared mutable state, and then you have to have locking and maybe a monitor that's keeping track of what's reading and writing to what. With Erlang, there aren't locks, and all of the kind of operating system process stuff is abstracted away from you. So you only work with these Erlang processes, and as you define Erlang, as you create Erlang processes, the runtime will smartly create operating system processes so that you can span across your cores. So without doing any work, you can take advantage of a huge server with 22 cores, and it will and create millions of processes that will span across all of them. You have no mutable state at all in Erlang, so you can't. So it eliminates the need for locks. The way you do inter-process communication is that each process has a mailbox, and you communicate through message passing. So if you have a main process that wants to spawn another process, it can have it send a message back, and the main process can receive that message. So you have two different things. You have spawning processes. Hold on. Let me show you this live in IEX. All right. So if we want to get the process ID of our IEX session here, we can bind it to self, and it will output this process ID. We can then write a function that will send us. It will send us. What do we want to send? It will send me a tuple hello with a string hello. That should work. And we can spawn a new process with this function. And so it has actually worked and sent us the message hello, but we haven't received it. So it's in our inbox. If I type flush, it will output the inbox, and you can see that we have this message, this tuple hello in our inbox. So now if I run this again and spawn it, and I write a little receive block, I can then pattern match on the tuple and say anything that looks like that starts with hello and sends us we're just binding string to whatever the string hello. Then I want to io.puts the string. And it worked, and we received hello. So that kind of very quickly shows you how you can spawn a new process. Now, if we wanted to do something more complex, let's go into our MISC application, and we'll write a function pmap. If you're familiar with most languages have something called map, where you take a list and you iterate over the list and call a function on each element. We're going to write that, but our little twist on it will be we're going to spawn a new process that will do all of the computation. We're going to get a list of process IDs, and then we're going to iterate over that list and receive all of the messages from those processes. So if I write pmap, it will accept a list and a function. We're going to need the current process, which will bind to me like we did before. And we'll take our list. I'm going to introduce a new operator here called pipe. It works like Unix pipe, where you can pipe the result of the last statement to as the first argument of the next function, and you can just keep piping all the way down and passing results. So I'm going to pass this to enum.map, which is an implementation of regular map in the enum module, which receives a list, but because we're using pipe, it will automatically send our list as the first argument, and a function that will act on an element. So inside of this, so our goal is to end up with a list of process IDs. So we need to, like we did before, spawn a function that will send me the result of our function on this element, being called on this element. And we should get a list of process IDs, and then we will pipe this to enum.map again and go over our list of process IDs, which we'll have as PIDs. Let's make this easier. I'll do the M down here. And we will receive tuples that look like our PID with a result. And we will output our result. All right. I think that is right. Hopefully, missing any do's or ends? I don't think so. Let's reload things. Dang it, 36 missed. Live coding. Yes, you're right. Thank you. All right, so now it loaded. Let's see if it works. We have our list. I like 1, 2, 3, 4, 5, so remember it's 15. And we need a function to pass to our pmap. So we'll say a function that receives an element, and it will square it. So then we can say miss.pmap and pass it our list and our function, and it should run forever. Wow. What did I do wrong here? Function.
Are you expecting PID to be a symbol?
Yes, but what am I doing? All right, so we map, receive an element, we spawn, and we send with our process and the result, which we then get our list of process IDs, and we map over that list. and receive the result. All right, I might just have to move on in the interest of time. But you, does everyone understand what I'm trying to do? How much time do we have?
15 minutes left.
15 minutes. It's pretty much the last thing I wanted to talk about. So there is a debugger. I haven't used it yet, so I'm not exactly sure. I haven't actually done anything real with Elixir, so in a way I have no business really giving this presentation. But I had messed around with it and I wanted to learn it better, so that's one of the reasons that I wanted to give it. So I'm not exactly.
Can I ask you a question about concurrency? So it's automatically mapped to your machine's number of processes. Can it be smart enough to map to a cluster of boxes, or you need to do something about that?
Right. So actually, the Erlang virtual machine in a way, will abstract all of that away from you. And then they also have this framework on top of it called OTP. And what does that stand for? It's like Open Telecommunications Platform. And basically, if I had run that mix command, I could have generated an OTP application that would have things like a supervisor that can monitor multiple nodes, or nodes can span multiple machines, and those nodes can have processes. So it supervises all of that for you and will manage it. All right.
So you mentioned that the writer of this language wrote it because he thought it would make it easier to make, I thought you said a web framework on top of Erlang, right? That was the purpose of writing this language? Did he get to writing the web framework?
Yeah, so there's a web framework in development. It is called Dynamo. So it's out on GitHub. Some people are using it in production. It's got a lot of Rails flavor to it naturally. I haven't really messed with it yet. I wanted to learn the language a little bit better before I built a web application in it. Man, I'm really bummed.
Do you have any feeling for what the framework structure is? I mean, I'm not familiar with Rails personally, but how does it? What are the components? Do you know?
I'm not sure. I imagine it's an OTP application, so it'll be a little bit different than I would think an MVC framework would be.
Yeah, that might be a good follow-on topic. Is how do you? I have no idea in a functional language how do you implement a web framework.
One other thing I wanted to talk about is another thing that Elixir has is something called a macro, which it borrows from Lisp, and it allows you to do metaprogramming. So we basically, if you're familiar with Ruby, we have kind of like a method missing type thing where we can on the fly create functions. So this test here is a macro that will create a function that looks like test underscore multiply underscore will underscore etc. And it will call this assert macro, which you can see is very smart. It can pattern match against all of these different operators. So we can use this same assert instead of saying like assert greater than, assert equal. We can just have one assert macro that can handle greater than or equal or whatever matcher that you want. So it's pretty cool. I haven't really dug in or written any macros yet. I'd say it's more of an advanced topic, but it allows you to create these domain-specific languages. You can see that this looks a lot like Minitest in Ruby or RSpec a little bit. So you could probably implement RSpec in Elixir. So I think I'll end there. We have some time for questions.
Yeah. See if anyone on the phone has any questions. Anyone on the phone have any questions?
Everything. It's like Libs, Smart Hub, and also it's like switching systems. Everything sounds familiar, little pieces.
Yeah, and it. I kind of like how it's this new language, but it's on top of this runtime that's existed for 20 years almost, and it's
The syntax is very old.
yeah, the syntax isn't.
It makes some of
Most language syntax is very stems from older languages, so it's not really different in that respect. And most of the newer modern languages are also like 20 years old, like Ruby and Python and all that. And Clojure and Scala are newer, but they're still several years old at this point. Anyone else?
Thank you.
Thank you.
Yeah. If you're bored and want to stick around, I'm going to try to get this PMAP working.
But